This is the solution video for section 8.2, problem number 22. All right, so the directions say for problems 20 through 29, use shells. So for problem 20 and 21, for 22 through 26, find the volume generated when the region bounded by the given curves is rotated about the given axis. All right, so y equals x squared. All right, so what is the graph of y equals x squared? So y equals x squared is a parabola with a vertex at 0, 0. All right, what about y squared equals 8x? Well, that's a sideways parabola facing to the right. All right, and so something like this. All right, now what about the 8? What does that do? Well, if I solve for x, if I have x equals 1/8 y squared, we would realize that the 1/8 makes the parabola wider than normal, right? But really, it doesn't matter because all I want is to get a drawing, and we realize that this is the region then that has been created, right? Now, we would need to know the points of intersection, right, for our limits, and so we're going to find our points of intersection. So how do I do that? Well, one way or another, I have to set the two equations equal to each other, right? So if I have y equals x squared, right, I could take x squared and insert it into y in the other equation. So I would have x squared equals 8x, right? And so this is x to the fourth. And then I can subtract the 8x minus 8x equals 0. So factor out x. X cubed minus 8 equals 0. So x equals 0, or x cubed minus 8 equals 0. And so x cubed equals 8. So x equals the cube root of 8, which is 2. So x equals 0 and 2. So this point intersects at 0, comma, well, 0, right? Because if y is x squared. All right, and here x is 2, so y is x squared, so y is 4, right? So 2 comma 4. All right, so now it told me to use the shell method, right? And so it says we're going to revolve about the y-axis, right? So if I'm revolving about the y-axis, remember the y-axis is a vertical line, so we're going to use a dx because that is parallel to the y-axis. All right, so we're going to use dx. So I write myself that little note, and now shell method, 2 pi integral of radius times height with respect to x in this case. All right, so radius, how far is the dx from the axis of rotation? Well, it's x minus 0, right, which is the axis of rotation, so it's just x. And then the height, the upper boundary minus the lower boundary. All right, what is the upper boundary? Now, keep in mind, our equations need to be in y equals form, right? Y equals is what needs to go in here. So y equals x squared is fine, but y squared equals 8x is not fine. So y equals plus or minus the square root of 8x. Now, remember, plus or minus. Well, it's the top half of this sideways parabola, so it's the positive. All right, so the positive root 8x is the upper boundary. So we have positive root 8x minus the lower boundary, which is this curve here, which is x squared, right? So this is my setup. Now, from what to what? All right, I'm integrating from left to right, so 0 to 2, right? Remember, these are the x values. All right, so now let's simplify a little bit. 2 pi times integral from 0 to 2 of, all right, so this root 8x is really like square root of 8 times the square root of x, or x to the 1/2, right? So I'm going to distribute the x, so I get the square root of 8 times x to the first times x to the 1/2. That would become x to the 3/2 minus x cubed, and then we're going to integrate with respect to x. So 2 pi integral, all right, so I have the root 8, all right, times x to the 3/2, all right, so that would become x to the 5/2 divided by 5/2, which is like multiplying by 2/5, right? All right, so I have 2/5, and then I have minus x to the 4th over 4. And we're going to evaluate from 0 to 2. So this is, once again, pretty reasonable. So 2 pi times, all right, I'm going to leave this stuff alone, root 8 times 2/5, and then I have x to the 5/2, so that would be 2 to the 5/2 minus 2 to the 4th over 4, and then minus 2 pi times, well, it would be root 8 times 2/5 times 0 to the 5/2 minus 0 to the 4th over 4. Of course, all that is just 0, right? All right, so next, now we have to simplify, right? If this is a free response question, we're done right here, all right? But let's say that this is multiple choice. We've got to keep going. All right, so I've got 2 pi. All right, now I've got root 8. What is root 8? Well, root 8 is root 2 times root 2 times root 2, right? Which is really just 4 root 2, right? So I have 4 root 2 times 2/5, right? And then I've got 2 to the 5/2. What does that mean? Well, remember, it means the square root of 2 to the 5th. So that means the square root of 2 times 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 the square root of 2. Well, when you think about it, root 2 times root 2 is 2 times another 2, so it's actually 4 root 2. All right, and then minus 2 to the 4th, which is 16 over 4, which is 4. All right, and then, of course, minus 0. So now, well, what do we really have? We've got a 4 root 2 times a 4 root 2. So what is that? Well, 4 times 4 is 16, times root 2 times root 2 is 2, so 16, right, times 2 is 32, times another 2 is actually 64, right? So I have 2 pi times 64, not 65, 64 fifths minus, all right, and then we've got 4, so that would become 20 fifths, right? All right, 20 fifths. All right, is that correct? That is not correct. I apologize. Root 2 times root 2 times root 2, that's actually 2 root 2. So this should not be 64. That should actually be 32. I'm so sorry. All right. So this is 32 fifths. All right. So 32 fifths minus 20 fifths is 12 fifths times 2 is 24 pi over 5.